Hello geometry students, and welcome to a video that summarizes transformations for us. So first, a definition of transformation. And all that a transformation is it's an operation that maps a figure from a pre-image to an image. Okay, so I'm going to write that down. An operation that maps a figure from a pre-image to an image. Okay, so there it is, and a pre-image is just the original figure. And what we're going to do on this summary is we're just going to look at 4 different transformations. One of them we've already discussed, which is reflections, but we're going to look at reflections again. We're going to look at transformations. We're going to look at a rotation, and we're going to learn a new word, which all of these 3 transformations, they together make up the isometries. So isometry means, basically means any one of these 3 transformations. And then we're going to look at one non-isometric transformation, which is a dilation. And by the end, we're going to see what isometry really means. And so we'll kind of understand that, why this is different. Okay, so let's first look at a pre-image. Okay, so here's a pre-image, A, B, C, and let's plot these points. So I'm going to plot 2, 1, 2, 7, and 5, 1. Okay, so I've plotted the points A, B, and C. I shaded this one, I drew the triangle, and this one in the first quadrant, this is the pre-image. So that's, in other words, that's the image, that's the figure before we've applied any transformation. Now let's look at a couple of transformations. Okay, so the image is the final figure after a transformation. Okay, so this is the final figure after the transformation, or after a transformation. Okay, now a reflection we've already talked about, and I'm just going to say here that it's a mirror image. There's lots of ways to define it. We have a different way of wording it. Before we called it a flip over a line of reflection. This time we're going to say pretty much the same thing with different words. It's a mirror image over a line of symmetry. Okay, so a mirror image over a line of symmetry. Now again, I want to stress this. There are many ways to say this, and we called it a flip over a line of reflection. It means the same thing. So these are just different. There's really no one way to, no one set of words that defines this. All right, and so what we're going to do is we're going to reflect the figure over the y-axis. Now we've already practiced this, so we're just going to do this now. Over the y-axis means this, remember this is the y-axis and this is the x-axis. So we're going to reflect it over here. You can use the rule that we already have. I'm just going to do it visually. So the B is 2 to the right, so I'm going to move it right over here, and this is going to be my B prime. The A is going to come over to here. This is going to be my A prime. And the C, which right now is at 5, is going to come over here to -5. So 1, 2, 3, 4, 5, and there is my C prime. Okay, and we're going to make this triangle. And I'm going to finish the triangle, and then I'll just pick a color because colors are fun. And there's the triangle, and I think I'll make the reflection blue. There's no one color. Anything is fine, whatever you have. Okay, and this is the reflection, or the reflected image. This is the reflected image. Okay, let's move on. Let's do something new now. Let's do a translation. So a translation is when we slide a pre-image without reflecting it and without rotating it. So we're just going to slide it. We're not going to turn it at all. Okay, we're going to keep the same orientation. So in other words, if B is on the top, B will remain on the top, A will remain on the bottom, and so on. So this is a slide. We slide the pre-image We slide it over with no rotation and no reflection. So we can't rotate it or reflect it, or it's not a translation. With no rotation and no reflection. Okay, so we're going to translate it according to this rule. Now this is the transformation rule, and it says to take the preimage points and move it -9 in the x direction. That means I'm going to move it to the left, because that's a negative x direction, and -7 in the y direction. So that means I'm going to move it down 7. Okay, so I'm going to go back to my preimage, and I'm going to move it to the left 9. So I'm going to start out with point A. And I'm just going to count. I'm going to count to the left 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then down 7. So 1, 2, 3, 4, 5, 6, 7. There's my new A. That's A prime. I'll call that A double prime. Okay, we can actually put more than one of those tick marks. That's A double prime. Now I'm going to do the same thing with B and C. Okay, so you can now see the translated image. So this is a translated image. Translated image. Now I'm going to show you something kind of cool. Okay, I'm going to get a pencil and my ruler, and I'm going to draw a line from A to A prime. Okay, this is, I could draw one from B to B prime or C to C prime. I'm just picking this one because it's out of the way of the other transformations. Now this, I'm going to put a little arrow there, and that line that I drew is not really a line. That line with a little arrow at the end is really called a vector. Now if you look at that vector carefully, you can see that from the initial point of the vector to the final point of the vector, it actually went down 1, 2, 3, 4, 5, 6, 7, and it went over 9. That's the vector that's represented by this transformation. When we talk about translations and focus on that one topic, we're going to see that all translations have a vector associated with each point going from the preimage to the final image. There's always a vector. And a vector is just a fancy word. You've probably heard it before but never knew quite what it was. Just a fancy word for a segment that has a specific length and direction. So it's got to go in this exact direction, or it wouldn't be the translation that we were told to graph there. Okay, so let's move on and let's do a rotation. Okay, so now we are going to rotate the figure 90 degrees clockwise. Now rotating it 90 degrees clockwise is a little bit tricky, and I'm going to kind of show you how to think about it, and we're going to analyze this more closely once we really focus on rotations. So here's what we want to do. We want to imagine I'm going to take B because I kind of just drew something that's in the way of A. All right, I want to imagine that we have a hand of a clock here. That's like a hand of a clock. And I want to make that form a 90-degree angle. So I want to try to figure out where's a 90-degree angle. And I say right about there looks like it's a 90-degree angle. I hope I got that right. But this looks like a 90-degree angle right here. So that would be rotating B. Now we just have to make sure it's the same length. And we can kind of predict where it's going to go, because a lot of times with these transformations, the numbers don't really change. They change sign or something, but they don't, like, the numbers themselves are still there. So if this one, B, was originally the point 27 right here, that's the point 27, then it looks like a 90-degree rotation might just be at 7, -2. And that is it. So that's going to be our B triple prime. That's B triple prime. And when we do the same thing with the other 2 points, we're going to get what looks like it's going to be a clear rotation. So I'm going to follow sort of the rule, just kind of say this out loud one more time. I went from 2, 7 to 7, -2. So I'm guessing I'm going to go from 5, 1 to 1, -5. So 1, -5 is right there. And I'm guessing I'm going to go from 2, 1 to 1, negative 2, which is right there. Let's see what happens. So this is A triple prime. Like I said, we're going to analyze this more closely right now. We're just looking to see what these different transformations are. Okay, so we've got a line there. Let's see if it looks right. We've got a line there. We've got a line there. And we've got a right angle there. Okay, now let's make this, how about red? This, by the way, is a right angle, so we expect to have a right angle. I just kind of threw that in there because it helps me to recognize that I did my rotation correctly. So this is a rotated image. Okay, so if we were in the class right now, I would be giving everybody a piece of tracing paper. If you have tracing paper, why don't you get some out and do what I did right here, which is to trace the triangle ABC and also trace the letters ABC. And then I also trace this line that I drew from the origin from 0, 0 up to B. And so pause the video and get some and do that if you have some. And if not, just have to watch. Okay, so here's what we're going to do. We're going to take this figure. Now watch this line. I'm going to rotate this line. Now I didn't draw that line I didn't draw this line on the tracing paper. But what I'm going to do is I'm going to rotate this, putting my pencil tip at the origin, and I'm going to rotate it until this line lands on the one that I think is 90 degrees right there. So notice the line is right at the 90 degrees. I rotated it, and look where the triangle is. Not only look where the triangle is, but notice that A double prime matches up. So the points match up too. The A, the C, the B, they all match up. They're turned sideways, but this is my B, right? Okay, so that's a rotation. So that brings us to our definition of an isometry. And an isometry is any reflection, translation, rotation, or combination of any of these three transformations. And as long as that's the transformation, and as long as it's an isometry, then what's super important here is that the shape and size is not changed. We call that congruent. So this is actually a definition of congruent. Okay? Now let's look at our last transformation, which is a non-isometry, because the shape will remain the same, but the size will change. So let's go ahead and map these 3 points. So let's sketch these 3 points. Okay, so let's take a look at this. I graphed the triangle. It's a pretty small triangle with 0, 1 and 2, 0, 0, 0. It's a very small triangle. And I'm going to apply this transformation now, which is 2 times x and 2 times y. Let's see what happens. When I multiply 0 times 2, I get 0, right? And same for both coordinates. But when I multiply 2 by 2, I get 4. So there's a 4, and then 0 times 2 is a 0. And here is another 0, but when I multiply 1 by 2, I get 2. So these are going to be my new points of my transformed image of this triangle under a dilation. So let's go ahead and plot those new points. Well, 0, 0 is already there, so that's no big deal. I'm going to do this in red. 4, 0 is right there, so there's my new B, that's B prime. And 0, 2 is right there, there's my new C, that's C prime. And A prime and A are the same thing. All right, so let's plot this new triangle, and you can see what's happening here. This new triangle does stay the same shape, but it got bigger. In fact, it got twice as big. That's the dilation. So our new triangle, which I'm just going to shade in red, the new triangle is twice as big as the original little triangle in here. Okay, and that's the dilation. Okay, I hope you found this video helpful. That's the 4 transformations that we're going to start with. Later on, we're going to look at one more transformation that's called an anamorphic transformation, but that's going to be another week or so. All right.